There we go. So we will begin our class with what is a quadratic function. Now, in the past, we have been working with this, but like I said, some of you may have forgotten about this, so I'm gonna explain it again. So what is a quadratic function? All right, we have a definition over here. A quadratic function is any function of the form ax squared plus bx plus c. Now, these a, b, and c, these three, are any possible number that you can imagine. A, B, and C are real numbers. Every single possible number that you can imagine. These can be decimals or negatives or fractionaries or maybe even roots. This can be any number that you imagine. If you have something like this, you have a quadratic function. Now, there is a problem, though. There is a problem. A has to be different than 0. This is supposed to be different. Sorry, there was supposed to be a line here. I don't know what happened. The first coefficient, A, cannot be 0. Why? Okay, if we change A for 0, then we would have 0 times x squared. And every single number times 0 is 0. Right? So we would have 0x squared equals 0. So we will have 0 plus bx plus c. And this is a linear equation, not a quadratic. So by making this change, A cannot be 0. Otherwise, we will have a linear equation, all right? So what would be the domain of the function? That domain of the function, we will see it later upon the explanation. All right. Let's continue with a simple example, right? A simple example of a quadratic function is f of x equals x squared. This is a quadratic equation. Now, I said at the beginning, you should have this presentation, ax squared plus bx plus c. In here, you only have the ax squared. So what happened with the rest? Okay, the rest is there, but the values of b and c are 0 as well. Look. A is 1, so we have 1x squared plus 0x plus 0. 0x plus 0. So we do have the same form of the equation, ax squared plus bx plus c. We do have the same form, only that the coefficients and the constant value are zeros. All right? Now, we can create a table of values for this function. We can create a table of values. This will be our table of values. Remember, how do you create a table of values? Tabulate. How do you tabulate for this function? You just give a bunch of values for x. This is how you do it. I decided to give values from -3 to 3. So -3, -2, -1, 0, 1, 2, and 3. I decided to give these values. I could have given more, and I could have given less, and I could have given different values than this. But I decided for this. Why? Because I feel like these are the easiest. So whenever you tabulate, you give values for x. You invented those values. You decide those values. And then you replace those x's in the equation and find the appropriate values for x of x, for f of x. So let's do the example. In -3, you replace -3 here in the x. So you're going to have -3 squared. -3 squared will be 9. So that is why we have a 9 in here. Same with -2. -2 squared, if you replace the -2 for x, -2 squared will be 4. So we have a 4 over here. If you do the same with every single value, these are going to be the results of f of x, right? Now, you can use this table to create a graph of the function if that is what you want. And this will be the graph of the function. Each and every one of these pairs is a point. So the value -3,9, -3,9 is a point. Look at that. -3 for x and 9 for y. So over here in the corner is our first point. If you want to find the second one is -2,4. So -2 in x and 4 in y. Look at that. Here will be our second point. Sorry. Right? If you do the same with every single value, every single pair, you will have a bunch of dots that then you link together to create a function. All right? Beautiful. But we have another form of a quadratic function. There are a bunch of forms. Just like in linear equations, we had the general form, and then the slope-intercept form, and then the point slope form. Just like in linear functions, we had three possible forms of a linear function. In here, in quadratic functions, we also have possible different functions, possible different presentations of the same function, right? This function is called the vertex quadratic form. The vertex form. Why it is called the vertex? Okay, because in this presentation you can see which is the vertex of the parabola. Now, if you're kind of lost, let me explain that a little bit better. The vertex is this point over here. The top of the mountain, if you were to call it like that. The lowest possible point in the U, right? If we have a parabola like this, then over there will be the vertex. That is the vertex, okay? So in this presentation, you will have a vertex as well. And it is called the vertex form because you can see it. Look, in here, you will have an h and a k, and those are the values, h and k. Those are the values of the vertex. I'm going to explain that with an example. Always, examples are a lot better to explain all these types, all this information, right? So here, in here, we have a quadratic function. Why do we know this will be a quadratic? Because it is in the form of the vertex, right? We have the value of a, which is 2, the value of h, which is 3, and the value of k, which is 4, right? So this will be our vertex form of the quadratic function. Just in here, we can see what is the vertex of the parabola. Look, the vertex of the parabola is h, k. And we know h will be the value of 3. And k will be the value of 4, which means 3, 4 is the vertex of the parabola. Now look at here. There is a problem though with this formula. The thing in the middle is a negative. So even though we had a negative 3, I am not counting the negative 3 as the value of h. I am just counting the 3 because the negative, in this case, the negative does not belong to the vertex. It belongs to the formula. So discount the negative. All right. In the future, we will do a lot more examples of this. Here, I did a drawing of the function 2x minus 3, all of that is squared, plus 4. I did a drawing, and in here, this is the drawing. And you can see the parabola, this is the parabola, has a vertex in this point, 3, 4. Just like we found, 3, 4. All right. Pretty cool, huh? Beautiful. Let's continue with some properties of the quadratic function. By the way,
just a minute, please.
Danny?
Yes, you can go to the last page. A minute, please.
Absolutely. Yes, absolutely, buddy. So remember, guys, if you have any question, please do just like Danny did. All right. If you write it in the chat, I'm not going to be able to read it because I am in this form in the presentation, so I cannot see the chat. Okay. So if you have any questions, go ahead and open the mic and ask. All right. Just like Danny did. Now, if you want to take notes of this, go ahead and do so. But remember, you don't have to because you can always go to the PowerPoint presentation that we have in Phidias and download the PowerPoint presentation. Then all of these will be yours without having to write down anything at all. That is the reason why I created this presentation, right? Okay, Danny, can we continue, buddy? Are we good?
Yeah, teacher, thank you.
Beautiful. No problem, buddy. All right, let's continue. So let's continue with the properties of a quadratic function. We have a lot of properties, all right? So let's talk about those. The first one is that the graph of the quadratic function is a parabola. right? Parabola means is like a little U or like a little M, right? Now that parabola opens up if A is bigger than 0. So a positive value. Now, what is A? Okay, A is this value. This is the value of A. The coefficient of the x squared. If this value, if A is a positive, so bigger than 0, a positive, then the parabola opens up. And what we have is a U. It's an example. We have x squared minus 4x plus 4. So the coefficient of x squared is 1, right? There's nothing there, so we know the 1 is implicit. We have a 1 there. The value of A is 1. And 1 is positive. So the parabola opens up. We have a U. All right. But what happens if the A is a negative value, lower than 0? It opens down, right? If the parabola has a coefficient A negative, so lower than 0, this lower than 0 means it is negative. Then here's an example. We are going to have a parabola opening down. In this case, we have an N, a mountain, right? So A is negative 3 in this case. The coefficient of x squared is negative 3, which is a negative number. So it opens down. All right? This will be our first property. And it is an extremely powerful property. Because in the future, I'm going to ask you, okay, go ahead and do a drawing. Go ahead and do a drawing and a sketch of a quadratic. And knowing how it opens is going to do a lot for you. It's going to help you a lot. Believe me on this, all right? It's going to help you a lot. So if it opens up, then A is positive. If it opens down, then A is negative. Okay. Then let's try these exercises. Let's try these exercises real quick, all right? Real quick.
Profe, ¿te puedes devolver un segundo, por favor?
Absolutely, yes.
Gracias.
Let me know when we are ready, buddy. Ready now? Can I continue?
Yes, mister.
All right, beautiful. Now, before I continue, guys, I'm gonna slow down a little bit if that is what you want, okay? But look, I only have 20 minutes to do this. At 10 o'clock, we will have to go and do the classwork, all right? So I want to explain all of this so that you guys can go and do the homework, the classwork, sorry. So yeah, I can slow down, but remember, if what you want is to take notes, you can do two things. You can take a picture and write down the notes later, or you can just download the whole presentation and you don't have to take notes at all right? So yes, just you can just take a picture if that is what you want. If you want to write this down in your notebook, go ahead and take a picture and then write it down. All right, let's continue. Exercises. All right, exercises. So please in the chat, everybody, for question 1, identify if the first question in the chat, please, in the chat, don't open the mic, in the chat. Does the first question open up or down? Okay. All right, cool. Beautiful. We have some answers. 26 people answering. Beautiful, guys. Well, yes, it opens up. Beautiful. Why? How do we know? All right, so the coefficient of x squared is the value of a, right? So in this case, the coefficient is positive. That means that means it opens up. Beautiful, beautiful, guys. Danny? Danny? Okay.
No, teacher. I don't talk.
No, you didn't say anything? All right, cool, buddy, cool. All right, let's continue with the second one. In the chat, please tell me, does the second one opens up or down? Okay, we have a few people now, so you might be thinking this one is a little bit harder, right? Okay, 20 people now. All right, beautiful. I think that's enough. 20 people answering, that's enough. 23, 27 people, all right, beautiful. Okay, so yes, for all of you who answer, you are correct. The second one opens down. But what do you mean, teacher? You said if this value was positive, then it opens up, and look, it is positive. Yes, but the definition speaks about the value of a, which is the coefficient of x squared, not the first value that appears. No, 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 no. The coefficient of x squared. And the coefficient in this case is -7, because that is the value of x squared. -7. So in this case, -7 is negative, meaning this parabola opens down. All right. And let's finish with the last one, number 3. Does this one opens up or down? All right, a lot of people answering. Beautiful. Poof. 20, all right, 20, 27, 29, 30 people answering now. All right, beautiful. I think that's enough now. Beautiful. Thank you, guys. So yes, for all of you who answer, this thing is positive. All right. Now, how do you know? All right, you're going to have to amplify this expression. Now, you might be thinking the 7 is the coefficient. And right now, it is not. The coefficient is 1. But here, you don't find an x squared. You're gonna have to amplify the f of x. Amplify this expression. Resolve the parenthesis squared. And then multiply by 7. And then you will find that the coefficient is 7 indeed. Since 7 is positive, then this opens up. Beautiful, guys. Congratulations. Beautiful. All right, let's continue with more properties. We're going to have a lot of properties for quadratic functions. A lot of properties. So let's continue with this. All right. So properties of the quadratic function. You can find the y-intercept of a quadratic function by evaluating f of 0. Right? Now, in case you have it in the standard form, this is the standard form, ax squared plus bx plus c. This is the standard form, right? So the value of the y-intercept is always c. Why? Well, if you change x by 0, this is what it means. What do I mean by f of 0? Well, I mean change x for 0 and find the value of f. So if I change the x for 0, this x will be 0, and this x will be 0 as well. So you have a times 0 squared plus b times 0. Okay, so 0 squared is 0, and a times 0 is 0. So all this expression will be 0. Same thing here. B times x, no matter what the b is, will be 0. So you have 0 plus 0 plus c. Did you see? So if I change x by 0, everything in this equation will be just c. That will be the y-intercept. But if you don't have it in this form, you can just change x by 0 and find the value, right? Let me show you with an example. All right. So change x by 0. This is what you do. We have x squared, so 0 squared, minus 4x, so minus 4 times 0, plus 4. If you do this change, this is 0 minus 0, so 0, plus 4. Meaning that the y-intercept is 4. And you can see it here in a function. X squared minus 4 plus, minus 4x plus 4 is this little parabola over here. And this is the y-intercept. It is called the y-intercept because it is the interception with the y-axis. And here it is the interception with the y-axis. And you can clearly see it is passing through 4, which is the result that we get. All right. Beautiful. That is the y-intercept. Okay. Now, different functions are going to give you different y-intercepts. So this process has to be done every single time. But remember, in this case, we didn't have to do this. We didn't because, look, if the function is in standard form, the y-intercept will always be c. And this was in standard form. It was, look, ax squared plus bx plus c. Right? The value of a is 1, the value of b is -4, and the value of c is 4. So it is in in the standard form, meaning that we already knew the intercept, the y-intercept was 4. We already knew that. Okay, cool. Let's do some exercises then. In the chat, everybody, go ahead and write down what will be the y-intercept for the first function. Okay. All right. Okay, I did these exercises like this because they were absolutely simple. They were absolutely simple. So that's the reason, all right? That's the reason. I think everybody got it now. Beautiful, guys. 37 answers. All right, cool. 37 answers. And all of you said the y-intercept was 1. So you are correct, guys. You are correct. Let's jump into the second one. What will be the y-intercept for the second one? Okay, we have 3 answers now. Whoosh, 20, whoosh, 24, 30 answers now. Okay, you guys answer quickly. Cool. Beautiful. 0. 0 will be the y-intercept. Beautiful. Perfect, guys. And number 3, I am not going to ask you now because number 3 has a little complication. You have to do something more, right? And I want to see if some of you can do that at home later. If you care about math, if you're interested in math, go ahead and give 3 a practice. If not, that's okay. We're going to practice this later. So it doesn't really matter. All right?
Profe,
Yes?
¿puedes volver atrás un momentico, porfa?
Absolutely. Here?
Sí, gracias.
Absolutely, buddy. Go ahead and take a picture, please, so that we can continue. Can I go now, buddy?
Sí.
Listen. Thank you, buddy. Appreciate it. All right. So, again, properties of quadratic functions. We have talked about 2 properties, right? One, how it opens, either opens up or down. And the second one, the y-intercept, how to find the y-intercept. But now we're going to talk about how to find the x-intercepts, which are also called the zeros, which are also called the roots. So right now we have 3 possible names for the same thing. All right, go ahead and write this down somewhere, please. Whenever I talk about x-intercepts, it's exactly the same as zeros, which is exactly the same as roots. So in an example, I can say, go ahead and find the roots of, and I'm talking about the x-intercepts. So the interception of the function with the x axis, right? So here's an example. How do you find the x-intercept or zeros or roots? All right, you find it by equaling the function, the entire function, to 0. Here's an example. Find the roots of our function, -3x squared plus 2x plus 4. If this is the function, then you equal it to 0, right? Because that's what we have here. The function f of x, this entire function, will be equal to 0. So that is what I did here. I equal to 0. Now, it doesn't really matter where do you put the 0. You can put it to the right or like I did here, to the left. It doesn't really matter, right? The point is that once you equaled it to 0, you have to solve it. And the way we have to solve this is by using our beautiful quadratic formula. You guys remember the quadratic formula, right? Negative b plus or minus the square root of b squared minus 4 times a times c. All of that over 2 times a. this quadratic formula, we are going to have to use it when we talk about quadratic functions. Whenever we want to find the x-intercepts or zeros or roots, we are going to have to use our quadratic formula, right? And after we do the quadratic formula, one of those values is going to be positive and the other value is going to be negative. So here we have our possible values, right? If we round, look, this is the symbol for equality. This is the symbol for rounding. So this is the real answer, and this is a round answer. Our possible approximation is negative 0.869. And the second value, our second possible approximation, will be 1.535. Now, how did I approximate these values? Well, I just put it in a calculator. That's it. It's honestly not the way. You just put this in a calculator and there you go. You have your approximation. All right, now, how do you see these values in a function? Okay, this function is the one that we draw here. Negative 3x squared plus 2x plus 4. Here you have the function. It has a y-intercept of 4. Look, it passes through y in exactly the value of 4, which is what we had here. The last value, the value of c, is 4. So we knew that already. But the two values of x, the two x-intercepts, are going to be approximately negative 0.869, which is right here, look. That one, negative 0.869, almost really, really close to negative 1, but not quite. So right over there. Okay, and the second one is approximately 1.535, that one. So kind of in the middle between 1 and 2 because it is 1.5. So in the middle of 1 and 2, 1.5. All right, so there you go. This is how you find the two x-intercepts, or also called zeros, or also known as the roots. All right, guys? Beautiful. Now, the other property that I forgot to tell you is that the graph of the quadratic function is symmetrical. What that means is that we have a beautiful presentation of a u, or a beautiful presentation of an n. We cannot have something horribly drawn, right? Like when you draw this, try to do it beautifully, please, as perfect as you can. Now, I know, we all, even me, we all have difficulties when we draw. I mean, not all of us are artists, right? We have problems with these, right? So just try and give it a shape like this. Try to give it a symmetrical shape. All right. We have some examples in here in identifying the roots of each and every one of these functions. Now, I am not going to do this now. I was planning to do this, but we don't have enough time now. So we are not going to, because we would spend a lot of time if we do this right now. Okay? So sorry, guys, but we're going to have to continue. All right? Don't worry. We're going to do this later during the class. And you already solved some of this. You already did it. How do I know? Because in the past, you solved equations with quadratic functions, right? You use the quadratic formula. So you kind of know how to do this, right? This is not new. All right, let's continue. All right, more properties of the quadratic function, more properties. All right. In the past, I told you how to find the vertex, but if the function was in the vertex form of the function. But what happens when it is not in the vertex form? Okay, if it is not in the vertex form, we have a little formula to use. The parabola has its vertex at x equals negative b over 2a. The vertex is negative b over 2a. Now, b is the coefficient of x, the value of b, and a is the coefficient of x squared, the value of a. Right? These will be the coordinates. Right? I'm going to do examples of this later on the line. Now, since the vertex is a point, then that point has coordinates. Just like every other point, the vertex is compound of two values. One value for x and one value for y. In this drawing that I have here, the vertex is clearly seen as 0, 0. 0 for x and 0 for y. 0, 0. Two values, a comma in the middle, and parentheses, because that is a point. So how do we use that formula for x and create our point? How do we find the coordinates? Absolutely simple. Here you find the value of x by doing this formula. Negative b over 2a, you find the value of x. But then you take that value of x that you found and replace it in the main formula, in the main function, to find the y. 0, 0. So 0 is for x and then another 0 for y. In here you're going to have x, y. Take the value of x and replace it in the main function to find the value of x. All right? We're going to do examples of this later. Don't worry. Don't worry. We're going to do examples of this later. Okay, so now if the vertex could be a minimum or a maximum. What do I mean by a minimum or a maximum? Let me go back a little bit to some examples that I have were here. These two. Okay, so look, in here you can kind of see, yes?
One thing is that in the presentation, in the page where you explain how to find the x-intercepts, there is a mistake with a negative.
Is it? Oh, okay. Let's see. All right.
Like the answer is correct, but you forgot to put it on the denominator.
Sure. This one?
Because it's -6.
Oh, okay. I'm missing a negative, Sarah.
Yeah.
I appreciate it. Thank you. You are very welcome. Thank you.
Bye.
All right. So yes, 2 times -3 should be -6, right? Same as here, -6. But you're saying the values are correct, right?
Yes, because
Okay.
I did it on the calculator and the values are right.
All right. Okay. So this operation with a negative in here should give me this value, and this operation with a negative here should give me this value. Thank you, Sarah. I appreciate it. Guys, please, if you write this down, go ahead and do this change. All right, do this change. Put a negative here. I will, after the class, I will do this change for the people who are downloading the presentation. All right, for the people who are downloading the presentation, I will do that change. Okay, do not worry about this. Okay, so as I was saying, here, you can see two vertices, right? The first vertex that we can see here will be 2, 0, right? 2 for x and y for 0, right? Beautiful. And in here we have another vertex, but this vertex is not clear enough. It has to be with some decimals. Maybe 0.5, I don't know, 4.3. I don't know. Right? This one is a little bit more difficult because we don't have the grid to guide us, right? But we can still find those vertices. But this vertex is also called a minimum, this one. Why? Because the parabola opens up. Since the parabola opens up, the vertex is the lowest possible point, the point that is less than every other point. This one is called a minimum because of that. It is the lowest possible point. Look, this parabola can go as low as here. Then it is start increasing as well. So this vertex is called a minimum. But this vertex instead is called a maximum. Why? Because of the same reason, only that opposite. These points are all lower than the maximum, than the vertex. The vertex is the biggest possible point that the parabola has, right? No other point can go as high as this one. So this one is a vertex, a maximum, sorry. So a vertex can be a minimum or it can be a maximum. And how do we know that? How do we know if the vertex is a maximum or a minimum? All right, that's pretty simple. If the vertex is a maximum, if the value of A is negative. So if the parabola opens down. If it opens down, then the vertex is a maximum. Again, if the value of A is a negative. And if the value of A is a positive, then the vertex is a minimum. If this opens up, then it is a minimum. All right. And in here, we're going to cut it. We're going to finish that in here, and we're going to go do some practice, right? Now, in case you guys have any doubts, then you can always ask me. But I'm going to cut the video here, and I'm going to explain what the classwork will be, all right? Let's stop this thing.